Since the dawn of human civilization, we have become beings capable of critical thinking. Some may argue that many still lack these skills, but for the topic we are going to discuss today, let's consider that we have them. We have developed cognitive abilities to seek meaning in life, to believe in things we have never seen, something that our earthly companions do not possess. Since the beginning of society, people have been wondering whether we are alone in the universe or whether there is intelligent life like us somewhere else, beings that live among the stars. In the late 20th century, scientists converged on the basic idea of examining the sky and listening for non-random patterns of electromagnetic emissions, such as radio or television waves, in order to detect another possible civilization somewhere in the universe. The YouTube algorithm will only notice me if you like the video and leave a comment. Consider subscribing to the channel. In 1960, astronomer Frank Drake pointed the giant radio telescope at the Green Bank Observatory at two sun-like stars for 150 hours in the hope of finding some evidence of alien life. Although Drake's search was unsuccessful, it sparked humanity's ongoing quest to observe the cosmos in an attempt to answer a huge existential question: are we alone in the universe? Drake's initial search for alien life led to the founding of the SETI, Search for Extraterrestrial Intelligence, which is a series of programs aimed at searching for intelligent life beyond our solar system, mainly by trying to intercept their radio signals. But throughout the history of SETI, interference from human-caused radio signals has been a persistent problem. Finding real extraterrestrial signals, if they exist out there, is not an easy task. Think of it as looking for a needle in a haystack. So how do we filter out the noise and find what really matters? How do we distinguish radio signals coming from space from unimportant radio signals from Earth? Astronomers needed a new method to detect technological signatures and radio signals. That's where a scientist named Peter Ma and his team from the University of Toronto came in. With artificial intelligence technology, they were able to detect 8 potential alien signals. Scientists have developed a new machine learning algorithm that can better identify potential alien signals from all the background noise on Earth. This initial search examined data from 820 nearby stars, totaling more than 480 hours of sky data collected with the Robert C. Byrd Green Bank Telescope as part of the Breakthrough Listen initiative. So, how does the machine learning tool work? Basically, researchers trained the algorithm to differentiate between potential alien signals and signals caused by human activity by simulating both types of signals. Steve Croft, a scientist on the Breakthrough Listen project at the Green Bank Telescope, said, "The key issue with any search for techno-signatures is to look for a needle in a haystack of signals, to find the signal that could actually be a transmission from an alien world." The vast majority of signals detected by our telescopes originate from our own technology, GPS satellites, cell phones, and things like that. Peter's algorithm gives us a more effective way to filter through the haystack and find signals that have the characteristics we expect from technosignatures. Although the algorithm is new and still being developed, it has already discovered 8 signals of interest. Scientists searched for possible technosignatures in 820 nearby stars from the Hipparcos catalog. And surprisingly, they have already found something. The 8 signals appear to originate from the direction of 5 stars, with distances of 30 to 90 light-years. They had never been seen before, until now, when scientists used traditional analysis methods, rather than machine learning technique. Although not conclusively proven as extraterrestrial, they are certainly interesting. The scientists explained that this means they have key characteristics that make them look like alien signals, but we still can't be sure. Further analysis is needed. However, there is a problem. Follow-up observations attempted so far have been unable to see the signals again. Astronomers will need to detect them again to study them more closely and try to determine whether they are really from deep space or just terrestrial interference. Astronomers had already detected the first candidate signal from Breakthrough Listen, called BLC-1, in 2020. It appeared to come from the direction of the nearest star to the Sun that has Earth-like planets, Proxima Centauri, but that signal was later traced to terrestrial interference. And before that, in 1977, a strong narrowband signal was detected by Ohio State University's Big Ear telescope. The signal appeared to come from the direction of the constellation Sagittarius and had the expected signs of extraterrestrial origin. It was called the WOW signal. The entire signal sequence lasted the entire 72-second window during which Big Ear was able to observe it, but has not been detected since, despite several subsequent attempts. Many theories have been put forward about the origin of the emission, including natural, alien, and human sources, but none adequately explain the signal. The WOW signal remains, as of July 2022, the strongest candidate for an extraterrestrial radio transmission ever detected. But now, if astronomers can definitively confirm the existence of these 8 signals this time around, then they will go down in history as the first confirmed alien signals detected. If they are not signals, then some scientists have many other hypotheses about how aliens could contact us. Their hypothesis is that highly advanced civilizations could alter the orbits of planets in their solar system to serve as a beacon of their presence to an external observer. The gravitational force of asteroids can be used to slowly move planets to new locations over thousands of years, causing them to have complete orbits in relation to each other in a fixed and specific ratio, or resonance. Natural gravitational interactions produce such resonances. For example, Jupiter's moon Io completes 4 orbits of Jupiter for every 2 orbits of Europa and 1 orbit of Ganymede, forming a chain of 2:1 resonance. Similar patterns have been observed in other star systems, although those in which the proportions of each body differ rather than creating chains have never been observed. As a result, researchers believe that aliens may organize their planets into sequences unlikely to occur naturally, such as a series of prime numbers, 1, 2, 3, 5, 7, etc., or the Fibonacci sequence, 1, 1, 2, 3, 5, and so on. The researchers calculated that these relative orbits can persist for 20 billion years before losing resonance, surviving even the death of their host star. Now, the concept is quite similar to colossal structures on Earth, such as the largest pyramids of ancient Egypt, which were built to last beyond the life of a civilization. This beacon, too, could have the potential to outlast its creators. Even if we were to discover such a sequence, it would not prove the existence of intelligent life, and it's possible that the civilization behind it has long since disappeared. But traces of it may still be found. So, alien signals or planetary orbit patterns? What will it be? Whatever it is, we hope that first contact happens soon. Thank you for coming this far with me. Until the next video.